Alright.
Okay, so let's look at this now. Have you finished your truth table?
Mm-hmm.
Okay, so if they're both zero, meaning there's no signal coming here and there's no signal coming in from here, then on the outside there's going to be nothing coming, so it's zero. Is that what you put?
Yes. I
Okay,
put 0001.
zero. So now A has nothing in it, but B has something, right? This is
I
an
thought it had
OR
both
gate.
had to be one though.
No, that's only for an AND gate. An OR gate, both of them, only one of them has to
Oh,
be. It's this
that's
or
what I meant
that.
when I was asking the rule.
Yeah, I was saying the rule is the same for this, but here it could be any of them. As long as there's a
Oh,
1, there
okay.
will be a 1 on the other side. So there's going to be a 1 here, a 1 here, and a 1 here. Okay? And by the way, when I write this column, this first column in, so you know how I do like, I do it in a certain way. I put 0, 0, because this in binary is 0, right?
Yeah.
Then I do 0, 1, because this in binary is 1. Then I do 1, 0, because this in binary is 2. Then I do 1, 1, because this in binary is 3. Do you see how there's a specific order to this?
Yeah.
That's why I do it in that order, so you also need to do it in that order. Does that make sense?
Equals 3.
Yeah, 1 and 1, 1, 1 is 3, right? In binary, 1, 1.
Okay.
Does that make sense, or do you want me to explain why 1, 1 is
No,
equal
it
to
makes
3?
sense.
Okay. Yeah, if something doesn't make sense, let me know. Alright, so we have an AND gate and an OR gate. The next one is called a NAND gate. It is the opposite of an AND gate. And this is how you draw it. It looks just like an AND gate, except it has this bubble on it. And this means that you just do the opposite of what's there. Okay? So can you make the truth table for the NAND gate now?
Mm-hmm.
Okay, give it a try. So it's going to be just the opposite of the AND.
So if there's a 1, it's a 1.
So do the truth table for the AND gate first, and then just flip everything.
Yeah, but
So what
so
in
if
NAND?
there's a 1, it's a 1.
Um,
So there has to be both zeros for it to be a 0, or
for it to be a 0, both of them have to be 1. NAND just means not AND. Does that make sense?
for it to be a 0, they both have to be 1, and for it to be a 1, they both have to be 0.
For it to be a 1, it's anything except this case. So do you see how this
Anything
is the
except
AND gate?
two ones.
Yeah, exactly. So do you see how this is the
Okay.
AND gate? AND gate tells you they're all zeros except when both of them. So they're like AND. It means this and that, right? A and B have to be on. Here it's NAND, so it's saying if A and B are both on, then the thing is off, which means that it's just the opposite of this. So if it's 0, 0, 0, it's 1, 1, 1, 0.
So it's 1 if in any case except two zeros.
Mm-hmm. Mm-hmm.
Okay.
It is the opposite of an AND gate, right? An AND gate will tell us all ones, all zeros except for the last case. NAND is the opposite. Okay.
All
Now
right.
I'm gonna make a NOR gate. What do you
Hold
think
on,
a
I'm
NOR gate
almost
looks
done.
like? Yeah, go ahead, finish up. Yeah, let me know whenever you're done. What do you think? So knowing an OR gate looks like this, And knowing a NAND gate is just looks just like an AND gate, but with a bubble on it, right?
Mm-hmm.
Can you draw what a NOR gate would look like? So, what do you think it would look like?
A NOR.
A NOR gate. So a NOR gate would look just like an OR gate, but there's going to be one difference. And what do you think that is?
Um,
How did we turn an AND gate into a NAND gate? What did I put on it?
a dot.
Exactly. So it's the same exact thing.
An OR gate
Yep, you
with a
just put a
dot.
little, yeah, you just put a dot on the
Okay,
OR gate.
I want to write that down.
Yep, go ahead. And then also, I'd like you to make the truth table for what you think. Remember, it's just the opposite of an OR gate.
Column.
Yep, so let's try it. So 0, 0, 0, 1, 1, 0, 1, 1.
How do you know the order in the AP column?
It's always gonna be 0, 1, 2, 3 in binary. So 0 in binary
Oh,
is just 0. 1 in binary is 1. 2 in binary is 1, 0. Do you remember
so
that or
it's
no?
a 1 unless there's two zeros.
It is a 1 unless there's yeah, other way around. That's for an OR.
It's 0 unless there's two ones.
A 0, it's 1 only if that there's two zeros,
Oh, okay.
and then everything else is 0. So basically the
All right.
opposite of this. Okay, let me know when you're done with that
All
truth
right.
table. Then we can do, so we've done the AND, OR, NAND, NOR, and then
It's only
XOR.
a 0 if there's two zeros.
It is only a 0, it is only a 1 if there's two zeros.
Okay.
An OR is the opposite. So just think of the OR and then just do the opposite of that.
All right.
So you can even, like, you could even just do this. Like, you could even just say, okay, or. Are either one of these 0? No. 1? No. Are either one of these 1? Yes. Either one of these are 1? Yes. Either one of these are 1? Yes. And then just flip all of them because it's the NOR, and then you just erase everything. Like, you just erase this middle chunk here. Does that make sense or no?
Mm-hmm. That makes sense.
Okay, so it's a 1, 0, 0, 0. Okay, the next one that we have is called an XOR gate. It looks just like an OR gate. Oh god, that was terrible. It looks just like an OR gate, except it has an extra line underneath it. Does that make sense? And so it'll have
Mm-hmm.
an A signal coming out of it and a B signal too, and then Q is that. Okay, so XOR stands for exclusively OR. What that means is it's the same truth table. The truth table is the exact same as an OR, except it can only be one of the two. Okay, so I'll show you what that looks like.
An XOR.
Yeah, an XOR gate. It looks just, I'm gonna redraw this because it was a bad drawing. Okay, it's like this, then like that, and like that, and then it has an extra line like this. If you see the OR gate doesn't have the extra line,
Yeah, I see it.
this one does. And then two signals coming out of it. We have A and we have B. Okay, and so what this looks like is it's the only way it can be 1 is if only one of these is 1. So it can only be 1 here and here. It can't be 1 here because it's exclusively OR. Means only one of them. And then obviously it's a 0 here. So that's what the truth table looks like. Okay,
Okay, let
let
me
me know
write
if
that
that,
down.
yeah, write it down and then let me know if it makes sense too. Up to this point, does everything make sense to you? So we have an AND gate, both of them have to be 1. OR gate anything, if as long as there's a 1 anywhere, there'll be a 1 here. NAND gate is simply the opposite of an and then NOR gate is simply the opposite of an OR, right? It's only
Yeah.
XOR that might be confusing. XOR just means like any of them can, they have to, it can only be OR, exclusively OR. Okay, so the last logic gate that we're going to talk about is a NOT gate. NOT gate is so easy. It's just called an inverter. They also call it an inverter, but it just looks like this. So this guy here is called a buffer. It just passes the signal, but we put a bubble on it, and that shows that it's a NOT gate. And all it does is it only has one input, and it just flips it. It just flips your input. So if you put a 0 in, it's a 1. If you put a 1 in, it's a 0. It just flips the bit.
Oh, 1, 2. Okay.
That one makes
Let me
sense?
let me let me write that down.
Go for it. So now I'm going to give you some logic gates, and you tell me what would be the output of them. So
All
this is the
right.
first one here. And it has a 0, so 0 signal, no electricity going in this way, and it has a 1 going in this way. What do you think would be the output? So how do you do this? First, you
Hold
want to
on.
identify which gate this is. Do you have any
It's
idea
an
which gate
AND
this would be?
gate. It's an AND gate.
AND gate, right? And it has a 0, 1 coming in. An AND needs
Yeah.
both of them to be 1, right?
So
So
it's
what would
0.
it? A 0, perfect. Okay, I'm going to give you a couple, let's try B. Okay, B with a 1 and a 0 coming in, so what would that give you? Look
B
at
with
this.
a 0 and a 1.
Yeah,
It's a NAND gate.
exactly.
I didn't actually write down the rule. I just wrote down the table.
Well, think about it. What would an AND gate give you here?
Uh, 0.
And so it's a
So
NAND
NAND would
gate.
give you 1.
Perfect. Okay, what about this next one?
Next.
Hmm?
That's so XOR gate.
The top one is an OR. It only has one line.
Oh, top
The
one.
bottom one has a second one here.
Top one is an OR gate.
Exactly. And so is there an OR here? Is either one of these a 1?
No, so it's a 0.
An OR gate means that only one of them has to be a 1. It's this or that.
Oh, yes, right.
So it'll be a 1. What about this one here?
Um, the XOR gate.
Yeah, this is the XOR gate. Oops. This one is
What is
the
that one again?
XOR gate. This is the OR gate.
So only one. So it has to have a 1 and a 0 for it to be a
Exactly.
1.
Yeah, only one
So
of
it's a
them.
1.
Perfect. Okay, good stuff. Now we're going to do combinational circuits. So here I have an OR gate, and it has an input A and it has an input B. And that gets passed to a NOT gate with an output Q. So we make a truth table, same thing as we've done before, but this time we're going to put C in it and we're going to put Q. Okay, so what should I put for A? It's always 0, 0. What's next?
Um, 0, 1. 1, 0. 1, 1.
Perfect. Okay. Now you can just fill up the table in our shared document, but I'll do it here. So if this is a an OR gate, what would C be if both of them are 0?
An OR gate.
Yeah, it's an OR gate, right? Because it has that shape on it, like the curved type of shape.
Mhm.
So what do you think we'd get for C then?
Um, 0
C
has
is
to
right
be
here.
0.
So the output after the gate.
It has to be both 0
For
for
an
it to be
OR gate,
0
if we
with
go
an
back
OR.
to an OR,
It
OR
has
gate
to
is right here.
be both 0.
OR gate is right here. Either one of them have to be a 1.
For it to be a 1.
Yeah, for it to be a 1.
If it's
Both of
anything
them,
other than 2 zeros, it's a 1.
exactly. So this should be a 0 then, right?
Yeah,
And this should be a
1,
1.
1, 1.
Perfect. Then we put it through an inverter. So what does it do?
Inverts
Flips
it.
them, right? So it becomes 1, 0,
1,
0, 0.
0,
So that's the.
0, 0.
Now, instead of writing
Hold on,
this
let me
gate,
write that down.
yep, go for it. Go for it, Chief. I will crunch on my
Don't
carrot by the time.
don't burp again.
So instead of having two separate gates here, I could just make this a NOR gate, right?
Yeah, I could.
Right? Instead of writing these two separate, that's all a NOR gate is. It's you took an OR gate and then you put an inverter at the end of it.
And then it has a knot.
Exactly. So this is the next example here. It's an OR gate right here and an AND gate right here, but it looks a little different. So same thing, we're gonna make our truth table, but this time we have a couple of signals. So we have C as
You know
well.
what? I'm just gonna take a screenshot of this instead of writing it down.
No, I'll write it down, write it down. If you write it, I know it takes longer, but if you write it, it'll stick in your head better.
All right.
So yeah, even if it takes longer, don't worry, write it down. Okay, so here, it's only A and B we have to change. Everything else is based off of A and B. Okay, so here we would do same thing, 0, 0, 0, 1, 1, 0, and 1, 1. Okay,
Mm-hmm.
so if we look, C is the output of the OR gate, right? So if the OR gate gets a 0 and a 0, C will also be 0, right?
Mm-hmm.
If the OR gate gets a 0 and a 1, well, it's an OR gate, so it's going to have a 1. What about the next two here? What would C be here?
See these nuts. C would be 1.
And 1. Okay, perfect. CD's nuts. All right. Then let's look at D. D is just B. So whatever B is D. So 0, then a 1, then a 0, and then a 1, right?
Uh-huh.
Now, C and D both go through an AND gate. AND means that both of them have to be a 1, right? So if
Yeah.
C is a 0 and D is a 0, Q will be a 0. If C is a 1 and D is a 1, what will Q be?
1.
If only C is 1, what will Q be? QB.
0.
QB. Quarterback. Alright,
1.
1, 1, 1, right? And there you go. That's the final truth table.
All right, let me take a picture. I mean, write it down.
Yeah, write it down. This right here is the final truth table. Make sure it makes sense to you too, because yeah, there's no point in writing it down if you don't even understand it, and that's why I'm here to help you understand it, right?
Yeah, I'm into fitness. Fitness